Okay, so I hope my screen is visible to everyone. So let's start our second lecture on discrete mathematics.
Yes.
Yes, so we will resume our previous lecture only. So we were discussing GATE 2014 like question, and I have given you as a homework. So let me do it. Okay, so from these two, we can take Q as common. So we will get P plus P bar R. And P bar Q R bar S. So by absorption law, it will become P plus R. Then P bar Q R bar S. So it will become PQ plus में QR plus में P bar Q R bar S. So now from this and this, what we can take common, Q as common, R plus में R bar P bar S. So yes, so take it as this thing as x. Okay, r plus में r bar x, so it will become r plus x. Now, so finally, what we will get p q plus में this. Now, okay, so p q plus में q r plus में p bar s by absorption law. p q plus में q r plus में p bar q s. Yes, so finally. So yes, from here we can take Q as common. If we take Q as common, we will get P plus में P bar S plus में QR. Okay. This QR is as it is, and from here I have taken Q as common. So by absorption law again, it will become PQ plus में QS plus में QR. I hope I have made the point clear. So P plus में P bar S, it will become P plus S. So I have bypassed that step and I have directly written QP plus में QS. Plus में QR. Okay. So finally, Q can be taken as common. P plus में S plus में R. That's it. So this is my final answer. So Q is common and P plus में S plus में R. Okay. Yes. So you can take snapshot or something for this, and I will jump to the next slide. Okay. So I'm jumping now. So now we are going to start derived operators and properties. So basic operators we have completed. Okay, we have completed the basic operators and their properties. I have completed this topic. So now I am jumping to the next topic, that is derived operators and properties. So first of all, please try to remember what are the derived operators: NAND, NOR, XOR, implication, double implication. Total 5 uh, derived operators were there. So let me draw the truth table for you. So NAND is nothing but opposite of AND. Okay, so AND will be output of AND gate is true when both of its inputs are true. Na? So this will become true, and here we will have false. So we will apply not over it. So finally, what we will get, 3 times true and 1 time false. Nor means opposite of or. So when both are false, or is false, so nor will be true. When any one of them is true, then or is true, so obviously it will become false. Yes, XOR means when inputs are different, then it is true. Otherwise, it will be false. Like this. Okay. So when inputs are different, it is true. I think you already know all these things. These are very basic things. Okay. P implies Q. How P implies Q will look like? So it will be true, true, false, and true. You have to remember this. Okay. So P implies Q. So I will show you in today's class only what exactly is P implies Q. So you can think of like this: if P, then Q. Okay. So it will be true everywhere except this. Okay. When P is true, Q is false, then it is false. Otherwise, it will be always true. Next is double implication. Double implication is just like your X NOR. If you have studied Boolean algebra, then it is just like your X NOR. So it is like this. So it will be true and sorry. Yeah, it will be true and true, and here it will be false, like this. Okay, so it is nothing but opposite of your XOR. So here we have XOR, and opposite of XOR is XNOR, and XNOR is nothing but your double implication only. So XNOR is the term used in Boolean algebra, and double implication is the term used in logic. Okay, these are one and the same thing. Please try to take snapshot or something. I will jump to the next slide. Okay. Yes. I'm jumping to the next slide now. So this thing we have done in logic. So now let me show you in Boolean algebra how all these operators will look like in Boolean algebra. Let me jump to the next slide. Okay. So NAND, NOR, XOR, implication, double implication. So NAND is just like this, na? And then not. NOR is just like this, or then not. XOR is same like XOR only. Implication is just like P bar plus Q. In Boolean algebra, it is P bar plus Q, but in logic, it is implication. Double implication, I have already told you, it is just like your XNOR. So now let me show you 00011011. So I have already told you many times that in case of Boolean algebra, we will write like this 00011011. In case of logic, we will write, see the previous slide, true false type of thing. Okay. Yes. So now we will show you. So NAND. So opposite of AND. So here it will be 1, here it will be 1, here it will be 1, but here it will be 0. Now opposite of OR. So it will be like this. XOR. So when they are same, when both input are same, its output is 0. When both are different, then output is 1. So here I have shown you like this. P bar plus Q. So now you have got it 1 1 0 1. You can check it out. P bar. Let me show you. Okay. P bar. How P bar will look like? Just opposite of it. P bar plus Q you do. So you have to do OR between P bar and Q. 1 plus 0 will be 1. 1 plus 1 will be 1. 0 plus 0 will be 0, and then 0 plus 1 will be 1. So that is the truth table. Okay. Implication is just like P bar plus Q. XNOR, I think you already know, when both are same, when P and Q both are same, then its output is 1. Okay, otherwise its output will be 0. So opposite of XOR. Okay, you can check it out. Opposite of XOR. Okay, yes. So now let me show you some more important things. Okay, so when P and Q both are 0, so I can write it like this: P is 0 and Q is 0. But I can write it here: P is 0 and Q is 1. P is 1 and Q is 0. P is 1 and Q is 1. So whenever 0, then we will apply bar, and whenever we have 1, we will write as it is. Okay. So P bar dot Q bar, P bar Q, PQ bar, PQ. So whatever I have written here, these are known as min terms. Okay. These are known as min terms. So now according to min terms, we can write. Okay, so how we can write according to min terms? So from here I can say this is NAND. So wherever we have 1, we will write those min terms. Okay, so P dot Q bar, that is nothing but P bar Q bar plus में P bar Q plus में PQ bar. So this is nothing but P dot Q whole bar. So NAND, wherever we have 1, we will write those midterms. So here we have 1, so P bar Q bar. Here we have 1, P bar Q. Here we have 1, PQ bar. Similarly, if you want to write XOR, so how I will write XOR in terms of minterms? I will write it as P bar Q plus में PQ bar. You can check it out yourself. Here we have 1 P bar Q, and here we have 1 PQ bar. XNOR. How you will write XNOR? P XNOR Q. That will be P bar Q bar plus में PQ. You can check it out yourself. 1. So P bar Q bar. Here we have 1 PQ. P bar Q bar plus में PQ. That is XNOR. XOR is P bar Q plus में PQ bar. Okay. Now see, since both are opposite of each other, XOR and XNOR are opposite of each other. So that means directly, indirectly, I will say that whenever we will apply whole bar over it, finally we will get P bar Q plus में PQ bar. You can check it out yourself. So whenever I will apply bar over it, bar means what? Complement. So whenever I will do complement, finally I will get this. Okay, let me show you. Just apply De Morgan's law here. Change the sign, break the line. P bar Q bar whole bar dot P Q whole bar. Okay. So finally, what it will become? So P plus Q. Okay, I think you have got it. Now, whenever I will remove this upper bar, so dot will become plus and double bar we will be having. So finally, it will become P plus Q. Okay, and in dot, what we will be having? P bar plus में Q bar. Okay, so finally, when we will solve it, PP bar 0, it will be cancelled. PQ bar plus में P bar Q. You can check it out yourself. QQ bar will be cancelled out, and I have told you this thing only. So now the main basic thing is that whenever I want to do, we have X naught, and I apply bar over it. Finally, it will become XOR. Okay, I have proved it properly to you. Okay, so finally, directly and indirectly, I can say like this also: P bar Q bar plus में PQ whole bar. It will become P bar Q plus में PQ bar. I hope I have made the point clear to everybody. Similarly, if I apply bar over it, so that means I apply bar over it. Finally, what I will get? I will get uh, P bar Q bar plus में PQ. Without solving it, I am telling you. Please, it's homework for you. Please try to solve it yourself. Okay, you will get the same answer. I hope I have made the point clear. So both are opposite of each other. XOR and XNOR are opposite of each other. And later on I will improve this point, that they when they are opposite, when they are not opposite, and so on. But presently you can think that XOR and XNOR are opposite of each other. Please take snapshot or something. I will jump to the next slide. So I hope you have taken it. Let me jump to the next slide now. Okay, so next is how to remember the truth table of P implies Q. So how you will remember it? Because many students get confused here that how to remember this. So let me show you. PQ. So false, 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 true, true, false, true, true. So P implies Q. So I have told you true, true, false, true. So many students get confused there. So I have made a very small shortcut. You will think that P is just like your Sunday. You can think that P is Sunday and Q means holiday. So P implies Q means Sunday implies holiday. So that means what? P implies Q means, I will show you translations in today's class only. But I think you have just a little bit idea that P implies Q means if Sunday then holiday. If Sunday then holiday. We will think like this. Okay. So we will do translation in today's class only. Don't worry about it. But I think you have got a little bit idea. P implies Q can be written like this: if P then Q. P implies Q is read in English like if P then Q. If P then Q. So P I have shown like Sunday, Q by holiday. So I will say if Sunday then holiday. So now what I am saying, see this. It is not Sunday and it is not holiday. So obviously this is true. It is possible. Na? See, whatever thing is possible, you will say like this. It is not Sunday and still there is holiday. Yes, it is true. So there are some holidays which are on known Sundays. This is also true. Now I am saying that uh, Sunday is there, but holiday is not there. That is obviously impossible. So I have written here false. I am saying it's Sunday and it's holiday. No problem. It's possible. So like this, you can remember to table of P implies Q. Okay. So the third thing is false. Why? Because I have given commitment that if it's Sunday, then it will be holiday. Now you are saying it's Sunday and it's not holiday. How it is possible? So finally, third is false. Okay, rest all are true. And why this is true? I'm saying it is not Sunday and still it is holiday. It is possible. Huh? We have many other days on which we have holidays. Okay, it's not necessary that only on Sunday we have holiday. Yes, and it's not Sunday and it's not holiday. No problem. I hope I have made the point clear. Please take snapshot or something. I will jump to the next slide now. Jumping now. So now we will study some properties. I have given you idea about basic derived operators. Okay, these are the 5 derived operators: NAND, NOR, NAND, NOR, XOR, implication, double implication. So this was the truth table according to your logic, and this was the truth table according to Boolean algebra. Okay, I have given you hint of everything. Now we will start the properties. Okay, derived operators concept is over. Now we will start their properties. Okay, I have told you in XOR that it is talking about differences. XOR is talking about similarities. If you are not able to follow, see this. XOR is talking about differences because it will be true when both are different. XNOR is talking about similarities because when both are same, either both are 0 or both are 1, then it is true, otherwise it is false. Okay. So directly indirectly I will say XOR is talking about differences and XNOR is talking about similarities. So now immediately I will say like this: E XOR Q bar. What will be this? So without solving it, I will say, see, we are trying to find differences between P and Q bar. So directly, indirectly, I am trying to find similarities between P and Q. So finding similarities means what? P X not Q. Similarly, P bar XOR Q, that will be P X not Q. Similarly, P bar XOR Q bar. Now see here carefully. Now I want to find differences between P bar and Q bar. So obviously I am finding differences between P bar and Q bar. So in P and Q also I am finding differences. So it will be P XOR Q. Please let me know if anybody is having any doubt here. Okay, please let me know how I have made this. If anybody is having any doubt, please let me know. Yes, should I log in from my mobile if somebody wants to chat? So if you are able to speak, please try to speak. Okay, it will waste our time. That I will keep on seeing my mobile and then I will keep on delivering the lecture. That will waste our time. So it's my humble request. If you are able to speak, then please speak with me. Okay, try to interact with me with voice. It will save our lot of time. Okay, okay then. Okay, that's really good. So P XOR is finding differences, XNOR is finding similarities. So we are finding differences between P and Q bar. Directly and indirectly we are finding similarities between P and Q. So it will become XNOR. Okay, let me jump to the next slide. So if we say P XNOR Q bar, immediately we will say we are finding similarities between P and Q bar. So you are finding differences between P and Q. Okay, similarly, P bar XNOR Q, it will be P XOR Q, and P bar XNOR Q bar, it will be nothing but P XNOR Q. Okay, if you forgot all these properties, don't worry. Please try to solve it. Okay, P XNOR Q bar. So how you will do it? Let's take Q bar as X. So P XNOR X. What you will do? P bar X bar plus P X. Now X is what? Q bar. So you will replace it by Q bar. Q bar bar plus P Q bar. So double complement, it will become Q only, P bar Q plus P Q bar, and it is nothing but you already know XOR. Okay, so it's a shortcut. According to property, I have given you direct answer, but in GATE exam, if you get confused or if you are not able to remember, you can do few steps and you will get your answer. So it's really very easy kind of thing. Don't worry about it. Okay, please take snapshot. I will jump to the next slide now.
The previous slide too.
Okay, let me do it. Yes.
Done, sir.
Okay. So let me sign in so that I can see the chat also.
Sir, can you repeat this once again?
Okay. So we are trying to find, see, XNOR means what? Similarities. So we are trying to find similarities between P and Q bar. if you try to find similarities between P and Q bar, so directly and indirectly you are finding differences between P and Q, because Q bar is opposite of Q. So you are finding similarities between P and Q bar. So indirectly you are finding differences between P and Q. So it is coming to be Px or Q. Yes, please let me know if anybody is having any doubt here.
Okay, sir.
Okay. So let me jump to the next slide now. So now next is commutative property. So commutative, I think you already know. For example, in case of and or, they were commutative. Now, so we in logic we keep on saying P or Q, that is same as Q or P. P and Q is same as Q and P. Okay, and in case of Boolean algebra, we keep on saying P plus Q is Q plus P. P dot Q is Q dot P, commutative, and you can prove it by truth table and all kind of things. It is really very easy. You can do it yourself also. You can make a truth table, and please, I think I should not waste time here. You can do it yourself. Okay, so a basic in you can say basic operators, I have shown you the commutativity. So here also now my question will be, what are the derived operators? NAND, NOR, XOR, XNOR, NAND, NOR, XOR, implication, and double implication. So I will write P NAND Q, P NOR Q. Let me write it proper. P NOR Q, P XOR Q, P implies Q, P double implies Q. So now I want to prove whether this and this are same, this and this are same, this and this are same, Q implies P, and Q double implication P. So now you can expand it and you can check it out yourself. Okay, P and Q, you just change it into Boolean algebra, you will get your answer. P dot Q bar. And how it will look like? Q dot P bar. So obviously P dot Q and Q dot P are same. I have told you. So their complement will be always same. So this statement is true. Similarly, how you will expand it? P plus Q whole bar. How you will expand it? Q plus P whole bar. I have told you P plus Q and Q plus P are same. So obviously their complement will be same. So now P XOR Q will be what? PQ bar plus में P bar Q. So how you will expand it? QP bar plus में Q bar P. Obviously, na. You take PQ bar. So first as it is and then bar, and then first bar, second as it is. So same is the case will be here. First as it is, second bar, and then first bar, second as it is. So clearly you can see na, P bar Q and PQ bar same na, because PQ and QP are same. So obviously PQ bar and Q bar P, obviously they will be same. So I think you have got it. Both are same, no problem. Okay, you can check it out yourself. QP bar and here P bar Q same. Q bar P and here PQ bar same, obviously. Okay, implication. So implication, I have told you P implies Q is nothing but P bar plus make Q. And how it will look like? Q bar plus में P. Now they are not same. You can check it out yourself. This is P bar plus में Q and this is Q bar plus में P. So both are not same. What about this scenario? Double implication. Double implication is nothing but your XNOR in case of Boolean algebra. Na? So it will look like PQ plus में P bar Q bar. And how it will look like? QP plus में Q bar P bar. So obviously PQ and QP same, P bar Q bar and Q bar P bar is same. So obviously it is same. So bottom line, or you can say the thing which you should remember is that except implication, let me write it with a different color pen. Except implication, all are commutative. All are commutative. Let me write it. All are commutative. If anybody is having any doubt, please let me know. Otherwise, I will jump to the next slide. Please take snapshot or something. I will jump to the next slide.
Done, sir.
Okay. Okay then. So let me jump to the next slide now. Next is associate. Associative property. I think if you remember, I have told you na, in Boolean algebra, P plus Q plus R, that is same as P plus Q plus R, and P dot Q dot R, that is same as P dot Q dot R. Okay, and why it is called associative, I have told you in the previous class itself, that whenever we are talking about q, it can associate with this plus also and this plus also. If it associates with this plus, it will become like this, and if q is associated with this plus, then it will become like this. So both are equal, I have told you in the previous class, and you can prove it by truth table and all these kinds of things. This is a really very easy task. Okay. So now we will talk about derived operators. Okay. So what are the derived operators? Associativity for basic operators I have told you in the previous lecture. So now what are the derived operators? NAND, NOR, XOR, implication, and double implication. Total 5 we have to check. So what about NAND? So how you will write P NAND Q NAND R? Is it same as P NAND Q NAND R? Let me check it. So Q NAND R, it will be QR bar. So now we will apply it with P. So it will become like. I hope I have made the point clear. So Q NAND R, it will be QR whole bar. I'm just changing it into Boolean algebra so that I get more clarity. Q NAND R, it will be QR whole bar, and then P NAND this entire thing. So this is taken as X. So P dot X whole bar. So I think you have got it. Now what about this scenario? PQ whole bar, okay, and R whole bar. P and Q is changed as PQ whole bar, okay, and then when we want to do this and, so I will say R and then whole bar, dot R whole bar. PQ whole bar taken as X, X dot R whole bar. So now please try to expand it by De Morgan's law. It will become P bar plus में QR. Okay, QR bar bar. So it will become QR double complement. It will be taken out. So it will become P bar plus में QR. What it will look like? PQ plus में R bar. Now clearly you can say these two are not equal. So NAND is not associated. NAND is not associated. This is really very important point, and it has been came many times. So NAND is commutative. NAND is commutative, but not associative. Please take snapshot or something. I will jump to the next slide now. Yes.
Done, sir.
Okay. So next is same. Okay. Now for NOR also you can check it out yourself. XOR I will do it in the next slide. So NOR, how NOR will look like? I think I should not waste time here. P NOR Q NOR R. Is it same as P NOR Q NOR R? No, these two are not same. You can check it out yourself. Okay, it will take hardly a 1 minute. Let me show you. Q plus R whole bar, P plus like P plus Q whole bar plus R like. So it will become P bar dot में Q plus में R, and it will become P plus में Q dot R bar. P bar Q plus में P bar R, and P R bar plus में Q R bar. Clearly both are not same. So nor is not associated. Finally, what we will get, I will say like this. Same. NOR is commutative but not associative. NAND is commutative but not associative. Now please take snapshot. I will jump to the next slide. Okay.
Okay.
Okay then. I'm jumping. Next is XOR. Same scenario. So I want to check P XOR Q XOR R. Is it same as P XOR Q XOR R? Let me expand it and we will get the answer. So P XOR Q R bar plus में Q bar R. I think you have got it. Huh? Q XOR R, Q R bar plus में Q bar R. So now we want to do XOR of this thing. So take it as X and take it as Y. Let me show you. The P will be remain as is because P is no problem. Let me take it as X. So P XOR X. What it will look like? P X bar. So P X bar. So P dot Q R bar plus में Q bar R. P X bar plus में P bar X. P bar X, how it will look like? Q R bar plus में Q bar R. So yes, so X bar na. So I will apply that. P X bar. So X I have written. I will apply here bar plus में P bar X. X as it is like this. So now I have told you Q R bar plus में Q bar R. This is XOR and I am taking complement of it. See this slide. I have proven you properly where I have done it. Where I have done it. Yeah, here. So I have told you na. P bar Q plus में PQ bar you take here bar it will become P bar Q bar plus में PQ. Why? Because XOR and XNOR are opposite of each other. I have told you P bar Q bar plus में PQ entire bar if we take finally it has become P bar Q plus में PQ bar. So that is nothing but XOR. Okay, so similarly, if I take XOR and I will apply bar, I have given you homework, na? P bar, Q bar, plus and PQ. You can check it out yourself. It will be like this only. So I, without wasting any time, so I will immediately, I will not expand here and do all these kinds of things. You can do yourself in home. So it will become Q bar, R bar, plus में QR. प्लस में I will expand it P bar Q R bar plus में P bar Q bar R. So I will expand now P Q bar R bar plus में P Q R plus में P bar Q R bar plus में P bar Q bar R. So this is my final answer for left hand side. Now we can solve right hand side also. So now I will pick up more speed so that we can save our time. PQ bar plus में P bar Q XOR R. So finally I will apply PQ PQ bar plus में P bar Q R bar plus में PQ plus में P bar Q bar R. Okay, I have bypassed one step. I think you have got it. So P Q bar plus में P bar Q. Or let me say it like this. X. This is X. So X R bar. So X as it is R bar. And X bar R. So X bar PQ bar plus P bar Q. I have applied the bar and I have got it PQ plus P bar Q bar and R will remain as it is. So now finally what we will get PQ bar R bar plus में P bar Q R bar plus में PQ R plus में P bar Q bar R. Now please check it out yourself. These two are exactly same. It is PQ sorry. Yeah, PQ bar R bar. Here, PQ bar R bar. PQR, PQR, no problem. P bar Q bar, P bar Q R bar, P bar Q R bar, P bar Q bar R. Same, exactly same. So finally, final conclusion will be what? XOR is commutative as well as associative. These kind of thing has been asked many times in GATE. Please try to remember it. XOR is commutative as well as associative. Yes, please take snapshot or something. I will jump to the next slide.
Got it, sir.
I'm jumping to the next slide now. XNOR. Okay, what about my XNOR? Let me show you. So finally, we will say like this: P XNOR Q XNOR R like this. Is it same as P XNOR Q XNOR R? Let me expand it. So when I will expand it, what I will get, QR plus में Q bar R bar. So same now. First we will write same QR and then Q bar R bar. Okay. You can write it opposite way also because X plus Y same as Y plus X. So you can write it anyway. It hardly matters to me. Main thing is we will get like this. So first, okay, let me write it in the sequence. Otherwise, some of you will get confused. First we will write complement form and then we will write same. So now P X nor this. So let me write it. Let us take this as X. So P X or X. So first complement. So I will take complement. So P bar dot this entire complement. I think I have told you many times. X nor and X or are opposite. Na? Q bar R bar plus में Q R. Whole complement it will become Q R bar plus में Q bar R. Like yes, plus what we will say same. So P dot Q bar R bar plus में. So finally what we will get, P bar Q R bar plus में P bar Q bar R plus में P Q bar R bar plus में R. Yes, so this is my final answer. Now let me do it this. So let me take a blue color. So what we will say, P bar Q bar plus में P X not R. Let me pick up more speed here. P bar Q bar. Okay. See, first we will complement it. Na? So P Q bar plus में P bar Q dot R bar plus as it is P bar Q bar plus में P Q R. Finally, what we will get, P Q bar R bar plus में P bar Q R bar P bar Q bar R plus में P Q R. Now please check it out yourself. They are exactly same. So finally, bottom line will be what? X nor is commutative and associative. That is the bottom line. Now, very interesting point will come into the picture. T X nor Q X nor R, we have got it, na? And like this, we have got it like this. After expanding it, we have got it. I think you have got the point. After expanding it, we have got this. Now see the previous slide. After expanding it, we have got it. Now see carefully, this expansion and this expansion is exactly same. Please try to focus here. This expansion and this expansion is exactly same. So directly, indirectly, what I will say, XNOR and XOR, which we were thinking that they are opposite of each other, but they are coming exactly same in case of T variables. But in case of two variables, they are opposite of each other. So let me show you. So P XOR Q XOR R, that is same as P XNOR Q XNOR R. But P XOR Q, that is not same as P XOR Q. Okay, rather they are opposite. P XOR Q, that is equal to P XOR Q whole bar. In case of odd variables, XOR and XNOR are same, but in case of even variables, XOR and XNOR are opposite of each other. Please take snapshot. I will show you all these things in the next slide. Please take snapshot. Okay. Yes. So XOR and XNOR, if odd number of variables, they are equal. If odd number, if even, then XOR and XNOR are opposite of each other. You have to remember this fact. Okay. So directly, indirectly, what I want to say, if I say P XOR Q XOR R XOR W, So what it will look like? P X nor Q, X nor R, X nor W whole bar. Okay, because there are even number of variables, so they are opposite of each other. But in case of odd number of variables, they are exactly same. Okay, so let me tell you something. If you want to dive deep into the topic, let me show you one more thing. Very important point. When XOR is true, XOR is true, or you can say XOR output is one and the same thing. XOR is true when odd number of literals are true. Odd number of literals, or you can say variables, are true. And XNOR is false when even number of literals are false. These are the two basic lines which you should remember. Okay, now you apply this definition. XOR is true when odd number of literals are true. See this. In XOR, see, XOR is true when odd number of literals are true. See, how many literals are true? 1. How many literals are true? 3. How many? 1. How many? 1. Okay, so 1 or 3. So odd number of literals are true, then XOR is true. Okay, yes. So and XNOR is false when even number of literals are false. Okay, or you can think like this also. Sorry, XNOR is true. XNOR is true. XNOR is true when even number of literals are true. Sorry for that. Even number of literals are true. Now see this. XNOR, na? See this. Even number of literals are false. Oh, XNOR is true when even number of literals are false. Even number of literals are false. Now see the definition. Even number of literals are false. XNOR is true. Even number of literals are false. Even number of literals are false. And here also even number of literals are false. No, zero means what? Even, na? So even number of literals are false, then it is true. Okay. So directly, indirectly, what I want to say is XOR is true when odd number of literals are true, and XNOR is true when even number of literals are false. So when we have odd number of variables, now try to concentrate. When we have odd number of variables, so XOR will be true when odd number of literals are true. So when odd number of literals will be true, so obviously even will be false now. Are you getting it? When odd number of literals are true, then even number of literals will be false if we have total odd number of variables. Hence, XOR and XNOR are same. That is the proof. So anyway, it was not required, but I have told you, and you will study all these things in digital logic. Okay, so you have to remember this fact: XOR is true when odd number of literals are true, and XNOR is true when even number of literals are false. So when we have odd number of variables, so when odd number of literals are true, then obviously even literal will be false. Okay. So I hope I have made the point clear. If anybody is having any doubt, please let me know.
So it can be even said vice versa. XOR is true when even number of literals are false.
XOR is true when even number of literals are false.
Yeah, the definition is given for the XNOR.
Even number of literals are
It's
false.
XOR in XOR, sir.
It is not the case. XOR,
In
see,
XOR.
P XOR Q is what? P bar Q plus में PQ bar. So you want to say XOR is false when even number of literals.
XOR is true when even number of literals are false. The same definition which we have given for XNOR can be applicable for XOR, as well as the definition of XOR can be applicable for XNOR. They have
No,
to
no,
be
no,
true.
no. Why see this? P XOR Q. So how many literals are true here? Only one literal is true here. Odd number of literal true, so XOR is true. So if you say even number of literals false, so how many literals are false here? Only one is false. You cannot say that.
But in the previous definition, sir, if when we have proved.
That was the accidental case, na? When we have odd number of variables, in that
Mhm.
case both are equal, na? Both are equal, and obviously then you can reverse the definitions. No problem in that.
That's what I mean to say, sir. Like as we have seen the odd numbers of literals now, the
Mhm.
definition could be interchanged.
Yeah, it can be interchanged, no problem. When we have odd number of variables,
Yes, sir.
but in case of even number of variables, they are opposite of each other. And
But
actual
in case
definition,
of even number of variables, so will the second definition fits? X nor is true when even number of literals are false. For
hmm,
X, we get even number of literals. So
for X nor, come again.
as you explain for X or taking two literals,
Mhm. No,
similarly,
these first of all, please. Actually, I am not going into digital logic. See, these are the variables, and here these are the literals. So if you say the literals are four here. We have four literals here, and variables are two. Literal means it can be you are taking instance of variable. It can be the true or false. It hardly matters to me. For example, see this. If I say the literals now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 literals are there, but variables are only three. Anyway, you will get confused here. Actually, I do not want to dive deep into digital logic and all these kind of things. We just try to remember this thing only. Okay, XOR is true when odd number of literals are true. So you have to check each and every min term, and in that min term you will check. So here odd number of literals are true. Here odd number of literals are true. Here also and here also. So how many literals are true here? One. Here one. Here one. Here three. Odd number of literals.
yeah, we are in X nor now. We are in
Yeah.
X nor. The definition which we have got here will fit both.
Yeah. So here odd number of variables, na, that's why. So you can see here, odd number of literal true, odd and odd, no problem.
And here itself we can say that when even number of literals are false,
Hmm.
X nor is true.
Yes, X nor is true. Yes, perfect.
इस दोनों जगह पे तीन तीन लिटरल्स मतलब हम लोग लेकर किए हैं ना सर, इसलिए दोनों को इंटरचेंज करके बोल सकते हैं हम लोग.
एक्चुअली देखो क्या होगा जब हमारे ऑड नंबर ऑफ वेरिएबल्स होंगे ना, और अगर मैं कहता हूं कि ऑड ऑड लिटरल्स आर ट्रू, सो
यस
ऑड
सर,
माइनस.
मुझे समझ आ गया सर, मुझे समझ आ गया, क्योंकि हम लोग जो सॉल्व किए हैं अभी प्रूव किए हैं ऑड नंबर ऑफ वेरिएबल्स लेकर प्रूव किए हैं,
यस.
तो जिसके दोनों आंसर्स सेम हैं, एक्स और इज इक्वल टू एक्स एक्स नॉर हो गया यहाँ पे, क्योंकि वेरिएबल्स को लिए हैं, जिस वजह से ये डेफिनेशन भी दोनों को इंटरचेंजेबली यूज कर सकते हैं.
यस
नो
यू आर
नहीं
करेक्ट.
सर, आई एम रियली सॉरी टू कंफ्यूज यू.
ओके यस यू
मैं
आर ट्रू.
आपके नाम में हाँ मिला रही थी सर, लाइक आप कुछ और समझ गए.
Okay, no problem. But even honge, then they will be opposite of each other.
यस सर, यस सर.
Okay. So now let me jump to the next slide. So now we will start implication. Okay. So now we have to check implication is associative or not. So how you will check? P implies Q implies R. Is it same as P implies Q implies R? Let me check it out. So we will change it into Boolean algebra. Q bar plus में R. So P implies this. So P bar plus में Q bar plus में R. Now what about this scenario? P bar plus में Q implies R. So P bar plus में Q bar plus में R. I think you have got it, no? Q implies R is what? Q bar plus में R. So now P implies this. So P implies this. So let us take this as X. So P bar plus में X as it is. So P bar plus में R. So now finally what we will get? P dot P Q bar plus में R. So obviously they are not same. They are not same. So implication is not associated. Okay. So bottom line will be what? Bottom line will be implication. I have told you in the previous slides. Implication is not commutative. It was not commutative. No? We have checked it. not commutative, and not associative. Implication is not neither commutative nor associative. You can think like this. This is very, very important point. Implication is not commutative and not associative. Please take snapshot. I will jump to the next slide.
Okay, sir.
Okay, so yes, double implication. Let me check it out. So P double implication Q double implication R, P double implication Q double implication. I have told you double implication is nothing but your X nor. So Q X nor R, P double implication. Okay, let me say it directly. P double implication, that will be, and I have proved you already that they are same. X nor is commutative as well as associative. I have told you. So finally, double implication will be DI is commutative and associative. Please take snapshot. I will jump to the next slide.
Done, sir.
Okay. So now we will see distributive. Distributive is very, very important. Okay, because there are lots and lots of questions. So how many derived operators we have seen? NAND, NOR, XOR, then implication, and then double implication. Total 5 we have seen. So out of these 5, they can pick any two. So 5C2, okay, multiplied by 2 also. So I will, don't worry, I will tell you all these things in combinatorics. I am just giving you the idea. 5 into 4 divided by 2 into 2. So 20 questions can be asked from this topic. Okay, if you have any doubt, please let me share it again. We have 5 operators and you can pick any two of them. So from 5 objects, if you want to pick any two, then formula is 5C2. I will tell you all these things in combinatorics. 5C2 is the answer. Now, why I am multiplying it by 2? Because I will say like this. Implication is distributive over XOR or not, or XOR is distributive over implication or not. So like this, they will ask like this. So P implies Q XOR R. Is it same as P implies Q XOR P implies R? Like this. So this means what? Implication is distributive over XOR. Like this. Okay. And XOR is distributive over implication or not? So I will say like this. P XOR Q implies R. So I will say P XOR Q implies P XOR R. Like two questions everywhere. So that's why multiplied by 2. So total 5C2, 5 into 4 divided by 2, total 10 questions, and multiplied by 2, so total 20 questions from here only. And if I add 2 more, and or, which were the basic operators, so totally how much we will get? 7 we will get. So 7C2 into 2. So 7 into 6, 7 6 the 42. So total 42 questions can be asked from this simple topic only. Distributive law. On distributive law, total how many questions? 42 questions can be made. And of course, I will not show you all the 42 questions. I can give you a small hint that they will say implication is distributive over or not. Implication is distributive over and or not. Like this, they will ask. Okay. So I have given you idea. So what they will ask? So the question will be implication is distributive over XOR or not. Implication is distributive over XOR. That is the question. And what is this question? XOR is distributive over implication. I'm reading very shortly, okay, just to save the time. E means distributive. XOR is distributive over implication or not. So they will ask you such kind of question. They will say which of the following statement is true or which of the following statement is false, and they will keep on asking questions. So wherever there is a variety, there are lots and lots of chances that question will be designed from that topic. So I have told you there is hell lot of variety here. Total 42 questions can be made from this single distributive law. Okay, so for example, they can ask like this: implication is distributive over or not? Implication is distributive over or. So how you will say P implies Q or R? Is it same as P implies Q or P implies R? Brackets. Okay. So they will ask you such kind of questions, and you have to be ready to answer such kind of questions, and they are really very simple. Implication is distributive over or not. So I think you have got it, na? Implication distributive over or. So now how you will check it out? It's really very easy. Okay, so what you will say here? Here you will say okay, P bar plus में Q plus में R. Very simple. And what about this scenario? P bar plus में Q plus में P bar plus में R. So finally, what we will get P bar plus में Q plus में R, because P bar plus P bar is nothing but P bar only. So P bar Q plus में R, and here also P bar plus में Q plus में R. So I will say yes, implication is distributive over or. They can ask reverse question also. Let me show you the reverse question. Okay, let me do it on the next slide. Please take snapshot. I think everything is visible on your slide. Please take snapshot. I will jump to the next slide now.
Done, sir.
So I will ask reverse question also. Implication. Sorry. Or is distributive over implication. Or is distributive over implication. So you will say like this: P or Q implies R. Or is distributive, na? So you will say P or Q implies P or R. Or is distributive over implication. P or Q implies P or R. Let me check it out. So P plus में Q, sorry. Yes, so P plus में Q bar plus में R. I think you have got it, na? Q implies R, that will be changed as Q bar plus में R. So P plus Q bar plus में R. So what it will look like, P plus में Q implies P, okay, let me do it in the shortcut manner just to save the time. P plus Q bar plus में P plus में R. So P bar Q bar plus में P plus में R. So this will become what? Absorption law. P plus में Q bar plus में R. Yes. So or is also distributive over implication. This is also true. 100% true statement. So please take snapshot. I will jump to the next slide. So similarly, they can make hell lot of questions. Okay. Let me show you one more question. No problem. So I think you have got it. Na? Total see this 42 questions can be designed. So I have just shown you one thing: implication over or and or over implication. So I have just solved two questions from the 42 questions. Now I think it's trivial. You can do yourself anything. You can do in homework. All these things you can do in homework.
Yes, sir. Yes, sir.
Yes. So finally we have done it. So I think I should not show you more question, and let me show you one question. Whose answer is false. Let me show you just one more question. I'm jumping to next slide now. So P implication is distributive over and. Implication is distributive over and. Is this true or false? Let me show you. P implies Q and R. That is equal to P implies Q and P implies R. So P bar plus में Q R. P bar plus में Q dot P bar plus में R. So P bar plus में QR. Yes, so it is also by chance it is also coming to be distributed. Okay. Implication is distributive over and also by chance I think yes. So how I have got it? P bar is matching. Apply distributive law. Okay, the reverse order. You will get it.
Yes, sir.
Okay. Okay, then I should leave it here only. I should not waste time here. You can check it out yourself, which is distributive and which is not distributive and all. Let me jump to the next slide. Yeah, I think it will not come. P and Q implies R. You can check it out. It will not come. P and Q implies P and R. Okay, so and is distributive over implication. Question is, let me write it with a different color. And is distributive over implication. That is the question. So for this question, you will first make this expression. P and Q implies R, P and Q and implies P and R. I think it will not come. So what you will say, P dot Q bar plus में R. So P Q bar plus में PR. And here PQ whole bar plus में PR. Okay. Yes. So P bar plus में Q bar plus में PR. So from this and this, yeah, and I think you have got it now. So these two are not same. Here we have PQ bar and here we have P bar plus Q bar. So obviously they are not same. At least I have shown you one example. So and is distributive over implication false. This statement is false. So implication is distributive over but and is not distributive over implication. So they can make a question like this. Which of following statement is true? So true. So first option they can give implication is distributive over and. B option can be and is distributive over implication. C option can be both and D option can be none. So what you will say by doing this, see implication distributive over and or not. You will not by heart all these things. I have told you 42 questions. How you will by heart them? You cannot do it. So the only idea is you have to solve like this in GATE exam. So finally after solution, we will conclude that and is implication is distributive over and. This statement is true. Okay, rest all false. Okay, yes. Now please take snapshot. I will jump to the next slide.
Done, sir.
So next is idempotent law. I think I have told you and or in case idempotent law was P or P is P, P and P is P. So now I want to check it out for others. NAND, NOR, XOR, okay, implication and double implication. Double implication is XNOR only, no problem. NAND. So P dot P bar, it will become P bar. So obviously P NAND P should be equal to P, but it is coming to be P bar. So idempotent law does not hold here. Idempotent law does not hold true for NAND. Same is the case here. P plus P whole bar. P plus P is P only. I have told you idempotent law. So it will become P bar. So here also idempotent law fails. XOR. So P dot P bar plus में P bar dot P. Just take it as Q. P XOR Q. P Q bar plus में P bar Q. So finally it will become 0. We want it should be P, but it is coming to be 0. Again idempotent law fails here. Implication. P bar plus में P. I think you have got it. Now P implies P will become what? P implies Q is what? P bar plus में Q. So it will become P bar plus में P. So it is coming to be 1. Again it is not idempotent. Okay, and because we should get P, na, only then it will be idempotent. So now P double implication to P. So how you will solve it? P dot P plus में p bar dot p bar. I think you have got it. Na? Double implication is XNOR only. So same and then bar. So same and then bar. So finally p dot p is p. Idempotent law. I think you have got it. Na? P plus p is p. This is in your Boolean algebra and this is logic style. And it will be like p dot p is p. Finally p dot p is p bar dot p bar is p bar, p plus p bar is 1 only. So again p double implication to p, it should come out to be p, but here it is coming to be 1. So idempotent law fails here also. So none of them is idempotent. Neither NAND nor XOR implication double implication. None of them is idempotent. So in case of AND we have got it, or we have got it and we have got it, but rest other idempotent law fails. Okay, let me jump to the next slide now. I'm jumping now. So now we will start in GATE exam. They can ask questions like this also. PQ, they have made their own operator and they are calling it as a box operator. It is just like a box, no? So it is a GATE question only, by the way. It is a GATE question. I do not remember the year, but this has been asked in GATE. So they have designed a box operator, and truth table is shown to you, and they will ask a question like this: box is commutative, box is associative, both or not. So commutative is really very easy. So how you will say, see, first of all try to establish some relation between them. P box Q is what? See the relation between. Okay, let me say like this. Whenever we have seen an operator like XOR, XNOR, so wherever we have one, we will write those minterms. Na? So here we have one, so I will write these two minterms. So what it will look like? So P box Q, it will look like P bar Q bar plus में P bar Q. So finally P bar will be common, Q plus Q bar will be over. So finally P or it will be cancelled out. Huh? So finally P box Q, that is nothing but P bar only. Okay. And if you have done a lot of practice in GATE exam, you will directly think, see the P double zero double one, and what about the box operator double one double zero? So obviously both are opposite. So P box Q will be nothing but P bar only. In GATE exam directly you can do it. But if you are not able to think like this, so don't worry. We have the basic idea. Wherever we have one, we will write those minterms. So P bar Q bar plus में P bar Q. So finally we will get it. So P bar will be common, Q plus Q bar will be gone. So finally we will get P bar. So box of P box Q is P bar. So now please see carefully. First one is complemented. You will think like this. So commutative means what? Q box P. Q box P will be what? First one is complemented, now so it will be Q bar. Now obviously P bar and Q bar are different, so it is not commutative. So A option is wrong. I think you have got it now. A option is wrong. So Q XOR Q box P is Q bar and P box Q is P bar. So obviously both are not equal. So it is not commutative. What about my associative? Associativity law means what? P box Q box R. It should be same as P box Q box R, like this. So how it what it will become? Q bar. First one is complemented, so it will be P box Q bar. What will be the answer? First one is complemented. Now forget about second one. I am just saying first one is complemented. You will get P bar. What about this scenario? You will get P bar box Q. So again it will be complemented. First one will be complemented. It will become P. Obviously P bar and P are not same, so it is not associative. So it is not associative. So answer is none. It is neither commutative nor associative. This is one of the best way to solve in GATE exam. Okay, and if you are not able to follow, then you can do by truth table also, and it will take hell lot of time. So I am giving you just like homework that you can do it with truth table also. Try to do it with truth table. So how you will do it? So you will write here. Okay, so Q box P. P box Q we have shown. So you will write here Q box P. So it will come like Q bar, huh? Okay, because we have finally got P bar. Okay, so how Q box P will look like? Where I should show will Q box P. So for Q box P, I have told you now. First one is complemented. So now you will say first one is complemented. It will come out like this. So obviously here we are getting 1010 and here we are getting 1100. So obviously both are not same. And so on. Please, you can do it. I should not waste time here. So that's it. So final answer is none. Please take snapshot. I will jump to the next slide.
Copy, sir.
Okay. So again, they have given another box operator. Now, if you have done good practice, you have good idea, then immediately you will say, sir, box operator is nothing but XNOR. And they are just asking the same question. Commutative, associative, okay, both or the none. So I have told you XNOR is commutative as well as associative. Answer will be C. And if you are not able to follow, if you have any doubt, then immediately you will think like this. So P box Q, wherever we have one, we will write it P bar Q bar plus me PQ. Now I think you will get it. Okay, it is nothing but XNOR. If still you are not getting, then do Q box P. Okay, so what we are doing, you are taking both complement and then you are doing same. So Q box P will be what? Q bar P bar plus make QP. So now I think this and this are same. So it will be commutative. Same associative and so on. It will waste our time. I have shown you it is associative and all. So final answer is C, that is both. So this has been asked in GATE also. All these which I am solving are GATE questions only. So they will just twist all the things. Okay, so they just want to check whether you have conceptual clarity or not. They will not ask direct question. XOR is commutative, associative, and so on. By the way, they have asked these questions also, but to increase the complexity, they will ask such kind of question. They will make their box operator, they will make a triangle operator, they will make a star operator, and so on. They can make any operator and they can give any name, and then they will ask you which of the following is commutative, associative, and so on. Okay, directly, many times they have been asked, NAND is commutative, but not associative, and so on. Okay, NAND, I have told you, na? NAND and NOR. NAND and NOR. What are the basic scene? NAND and NOR are commutative, but they are not associative. So they have been asked a hell lot of times these kind of questions. So direct question, the GATE exam will avoid such direct questions because many students will by heart all these things. Which of the following of it is commutative, which is associative and all, they will by heart. So they try to think, they try to focus on those areas so that students will think that what to do. Okay, they will not touch the areas which student can by heart. So obviously they will make their own question like this and they will try to confuse you. So if anybody is having proper idea that how to solve it, only then you will be able to solve such kind of questions. Okay. Yes.
So how are we supposed to get to this conclusion that is P box Q is equal to P bar Q bar plus PQ that you're writing it?
Wherever we have one, we will write those minterms. Na? So P bar, Q bar, PQ.
Okay, sir.
Yes. And in the previous question also, we have done like this. Wherever we were having one, we have written those minterms.
I followed it here, but there I just forgot. Yes.
Okay.
Yes,
Okay. So yes. So we have to remember all this kind of thing. Okay. And by the way, commutative and associative is really very, very important. Okay. So let me tell you. Or and okay. And then we have seen NAND, NOR, XOR, implication, and double implication. So commutative, associative, commutative, and or and NAND, NOR, XOR. This is not, but this is. So all of them are commutative except implication. Associative. This is associative. This is associative. This is not. This is not. This is associative. This is not, but this is associative. Okay, this is the final table which you should remember. Anyway, such kind of thing are now they are not asking such kind of questions, but you should know all these things. If you know By chance they ask such kind of question, you will immediately able to take it, and you will get more speed in GATE exam. So try to follow this table properly. And once you do the proof two to three times, immediately all these things will fit in your mind. So the basic idea is implication is neither commutative nor associative. Double implication is both commutative and associative. NAND and NOR are commutative but not associative. XOR is both commutative and associative. Or and okay, I think you have got it, huh? Or and XOR and double implication. Both are commutative as well as associative. NAND and NOR are commutative but not associative. Implication is neither commutative nor associative. Okay. Let me jump to the next slide now. Yes, I am jumping now. So see, these are some important terms which you should remember, and in GATE exam, many times question has been asked on these terms only. Okay, so they will what they exactly they will do? They will ask in options. You will find these terms: satisfiable, valid, contradiction, tautology, contingency. You should know all these things. So what is satisfiable? Satisfiable means at least one is true. So we have an expression like P implies Q and R and so on. We can have any expression. So in truth table, so you will say like this, na P, Q and R. So total you will write 8 combination false, 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 true and or total 8 combinations you will write. So accordingly here you will find somewhere will be true, somewhere will be false and such kind of thing. Total 8 combinations. Obviously, here you will get. We will make a truth table. I am not making it just to save the time. So, what do you mean by satisfiable? At least one true. Okay, so somewhere there should be at least one should be true. Then we will say satisfiable. Okay, that means we can satisfy. That's the satisfiable. Valid means everywhere true. So nowhere it should be false. It should everywhere it should be true. Then we will say valid. Contradiction means everywhere it should be false. Everywhere. Okay, so I think I have told you na P bar. Okay, so 0 0. In case of logic, let me write it like P and not P. False then true, true then false. So P and not P. So it will be false. Everywhere it is false. So in truth table we can see everywhere it is false. So it is contradiction. Tautology means everywhere it should be true. For example, I write like this: P or not P. It will be true. Everywhere it will be true. Na? Or so whenever at least one of them is true, answer is true. Or is true, and both are false. Okay, so I think you have got it. Na? Tautology means everywhere true. Contingency means at least one true and at least one false. This is really very important. Please try to follow it. Contingency means at least one true and at least one false. Satisfiable means at least one true. Valid means everywhere true. Contradiction everywhere false. Tautology everywhere true. So I think you have got it. Valid and tautology both are same thing. Valid means everywhere true. Tautology means everywhere true. Both are same. Just two different wordings. Contradiction everywhere false. Satisfiable at least one true. Contingency at least one true and at least one false. And see here and at least one true and at least one false. Then it is contingency. Okay. So what can I say? Satisfiable at least one true. So satisfiable means it can be valid also, and it can be contingency also. See the wording. Wording is at least one true. Wording is at least one true. So at least one true means what? All are true. That is also possible. When all will be true, it will be valid. So at least one true. So I will say somewhere it is true and somewhere it is false also. So it can be contingency also. So satisfiable means valid or contingency. So now in option they will say satisfiable but not valid. Then indirectly they are saying about contingency. They will say satisfiable but not contingency. Indirectly they are talking about valid. So they will not give direct option. They will say like this: satisfiable but not valid. It will become contingency. Satisfiable but not contingency. It will become valid. I think I have made the point clear to everybody. Yes. Now please take snapshot. I will show you the gate question regarding this topic. Okay.
Done, sir.
Okay. Yes. So yes. Gate 2004 question. So they are saying like this. They are giving it this much big formula they are giving, and they are saying satisfiable but not valid, valid contradiction. Now see here, satisfiable but not valid. See this, satisfiable but not valid. Directly they are talking about contingency. So they have not given direct option regarding contingency. They are saying satisfiable but not valid. So indirectly, this option is about contingency. So now how you will check it out? See, valid means what? Everywhere true, na? So finally, after solving it, you should get answer as true. Whenever you will get answer as true, that means it is nothing but tautology. Tautology or valid one are the same thing. Contradiction. So after solving it, you will get false as the answer. That means everywhere it is false. So then you will get contradiction. So let me check it out. What exactly we are getting. So P implies Q or R implies P and Q implies R. So let me solve it. So how you will solve it? Yes. So P implies Q or R. Okay. So P implies Q or R. It will be changed as P bar plus में Q plus में R. And what about this scenario? P Q bar plus में R. I think you have got it. PQ whole bar. X implies Y means what? X bar plus में Y na. So PQ whole bar plus में R. Now here again we have implication. Implication means what? This entire plus. I think you have got it. So this is what? See again. This is say X. This is say Y. X imply Y means what? X plus Y, X bar plus में Y. So you will apply bar here. I think you have got it. Finally, this is what we have to solve. Now try to solve it. Change the sign, break the line. P Q bar R bar प्लस में P bar Q प्लस में Q bar प्लस में R. So now what we can do? Yes, Q bar and here. So what it will become? Q bar will be common. 1 plus P R bar. So 1 plus something is 1 only. So plus में P bar plus में R. So P bar plus में Q bar plus में R. So I think you have got it, na? So I have not got 1, not got 0. I have got this much. So obviously it is contingency. Contingency means somewhere true, somewhere false. Okay. So whenever you get a formula type of thing, it is depending on something, na? So it will become contingency. Okay. Whenever we are getting true, or here since we are doing by Boolean algebra, so we will get answer 1. If we got answer 1, it is tautology. If we get 0, it is contradiction. Okay. 1 means tautology or valid, one and the same thing. 0 means contradiction. And whenever we get formula kind of thing, it is nothing but contingency. Contingency means somewhere true, somewhere false. Okay. So for example, I can say very simple example PQ and P plus Q. So 0 0 0 1 1 0 1 1 0 So obviously P plus Q is contingency. Why? Somewhere 0 and somewhere 1. Okay. And here what I have shown you, P and P bar. Everywhere it was false. Everywhere it was false, so it was contradiction. Everywhere it was true, so it is you can say valid or tautology. It is valid or tautology, and it is contradiction. Okay. And here somewhere true, somewhere false. It is contingency only. So finally we have got this formula, na? So it is nothing but contingency only. So your option is correct. It is GATE 2004 question. I think you have got the point how you will solve such kind of question. So I have just shown you one example. So now you can check it out from GATE previous year questions. You will be able to solve all such kind of questions. So whenever you have got the formula, you will immediately say it is contingency. Some formula kind of thing like this. And whenever you have got 1 as the answer or 0 as the answer, then respectively you can call valid or tautology or contradiction and all. Please take snapshot. I will jump to the next slide.
Copied, sir.
Next slide now. So we can think of implication now. Now we will study detailed study of implication. Implication detailed study we are doing now. So implication can be think like this also. P implies Q, that is if P then Q. So you can think like this. P is a small set and Q is the bigger set. So directly indirectly P is subset of Q like this. If you think like this, it will be shown by Venn diagram like this. So I will say whenever you are in P, like here, whenever you are in P, you are in Q also. So whenever P is true, Q has to be true. But whenever P is false, I really don't know. It can be either Q can be either true or false. Let me show you. When P is true, then Q must be true. When P is true, then Q must be true. But when P is false, then Q can be true or false. It hardly matters to me. For example, when P is false, so here P is false, so Q is true. Here P is false, so Q is also false. Okay. So when P is false, then Q can be either true or false. It hardly matters to me. But when P is true, then Q must be true. That is the basic meaning of implication. Now see this. P Q. P implies Q. False, 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 true, true, false, true. So what I have said, when P is true, then Q must be true. Na? So here I am saying Q is false. So obviously it will be false. When P is true, then Q must be true. So it is possible. When P is false, then Q can be either false or true. It hardly matters to me. We will get to it. So this is another way of seeing the truth table of P implies Q. So when P is true, Q must be true. But when P is false, it hardly matters to me. Q can be either true or false. I can say like this also. P Q. P implies Q. When P is true, Q must be true. Okay. Now similarly, I can say like this also. When Q is false, then P cannot be false. Sorry, P cannot be true. So P must be false. See this. When Q is false, P cannot be true. No? So when Q is false, P must be false. So you can, if you, see, actually these are very, you can say, peculiar type of detail which I am showing you. If you are able to follow, then it's okay. Otherwise, you can simply leave it. Okay, I'm just showing you the idea. When P is true, then Q must be true. See from here, when P is true, then Q must be true. For example, we are in Delhi, so and Q means we are in India. So whenever we are in Delhi, obviously we are in India. Na? Yeah, I cannot say I am out of India. Delhi is inside India only. So whenever we are in Delhi, we are in India also. Okay. So, but whenever we are not in Delhi, then we can be either in India or outside India. So we can be either in India or outside India. So whenever P is false, then Q can be either true or it can be either false. Now same scenario, when Q is false. When Q is false means you are here. So when Q is false, then obviously P must be false. So whenever you are outside India, that means you are never in Delhi. Obviously, how you can be in Delhi when you are outside India? Okay, so whenever Q is false, then P must be false. Like this, you can remember. Okay, but if P is false, then I cannot guarantee Q can be either true or false. It hardly matters to me. Similarly, when Q is true, then P can be either true or false. It hardly matters to me. Okay, when Q is true, see this. Whenever we are in India, then we may or may not be in Delhi. It hardly matters to me. Okay, and when P is false, that means we are not in Delhi. then we can be in India or we can be in outside India. It hardly matters to me. So same is the scenario. When P is false, then Q can be either true or false. It hardly matters to me. When P is true, then when Q is true, then P can be either true or false. It hardly matters to me. But when P is true, then Q must be true. When Q is false, then P must be false. This is the way to visualize the implication. Yes. Any doubt? Okay. Should I move to the next slide?
Yes, sir. Clear, sir.
So this is also very important. Make some star over it. It will be used in almost every subject. P implies Q is direct. Q implies P means it's converse. Not P implies not Q means inverse. And not Q implies not P means contrapositive. So you have to remember P implies Q and not Q implies not Q, both are same. And no need to by heart, you can check it out by Boolean algebra. P implies Q is what? P bar plus Q. And not Q implies not P means what? Q bar plus P bar. I think you have got it. Na? So this bar and plus this. So Q double bar is nothing but Q plus P bar. Obviously, Q plus P bar or P bar plus Q both are same. So both are equivalent. What about converse? Converse means Q implies P. So Q implies P means what? I think I have told you. Q bar plus P. So P bar plus Q bar plus P both are not same. They are not equivalent. And not P implies not Q. You can check it out yourself. Not P. P bar plus Q bar. So it is nothing but same only. So these two are same. So direct, converse, inverse, contrapositive. Direct is P implies Q. Converse means we just converse it. Q implies P. Okay. And direct and converse are not equal. Okay. Yes, inverse means not P implies not Q. Converse and inverse are equal. Okay. Direct is P implies Q. Inverse is not P implies not Q. Just inverse them. Not P implies not Q. Inverse. Contrapositive is not Q implies not Q. Okay. Yes. So this is contrapositive. So direct and contrapositive are same. Converse and inverse are same. I hope I have made the point clear. Let me jump to the next slide now. Please take snapshot. This is really very important point which you should remember. Okay, I'm jumping to the next slide now. E. So now I will show you some translations. P. I have money. Q. I will buy a car. P implies Q means if I have money, then I will buy a car. Like this, you will remember. So if I have money, then I will buy a car. Inverse means not P implies not Q. So if I don't have money, then I will not buy a car. So obviously, many of you will think that both are equal. But I have told you, see the slide. P implies Q and not P implies not Q. They are not equivalent. They are not equivalent. You can check it out. This is P bar plus Q and it is coming to be Q bar plus Q. This is P bar plus Q and it is coming to be Q bar plus Q. Both are not same. I am not saying mathematics is saying to you. So now you will think that these two statements are same. If I have money, then I will buy a car. So obviously, it means that if I don't have money, I will not buy a car. No, it is not the case. Please try to follow. They are not equal. I am just saying, if I have money, I will buy a car. Now, it does not mean that if I do not have money, I will not buy a car. I can take a loan. By loan also, I can take a car. So they are not equal. Okay. So same is the case with India also. So since you are computer science student, you have idea of implication and all. So now you have got the idea that they are not equivalent. If I have money, then I will buy a car. It is not same as saying if I do not have money, then I will not buy a car. They are not same. But poor Indians, they are not able to follow it. Those people who have not studied logic kind of thing, they are not able to follow it, and they will go to some saint, and saint will say, "Do this, you will reach the God." Okay? Now his implication, he's saying, if you do this, then you will reach the God. Now this saint is saying this thing, but poor Indians, they are not able to think like this. They will say, okay, so saint is saying if we do not do like this, you will not reach to God. He has not said it, but you will think like this. And by these things, most of the, you can say, Rai Jhagda and all these kinds of things are done in India. Okay, most of the uh, uh, you can say most of the fights are done because of these kind of things. Okay. So your religion and all these kinds of things, they are creating hell lot of problems in India just because of this thing. Because he is saying he is very intelligent person. Saints are not illiterate kind of thing. They are really very intelligent. They will say like this: if you do this, you will reach the God. That's the thing. But you will think if I do not do like this, I will not reach the God. And that is the problem where everyone is fighting in India. So try to follow it. If I have money, then I will buy a car. It does not mean that if I do not have money, I will not buy a car. Yes. So from logic, I have proved all these things to you. Yes. Please take snapshot. I will jump to the next slide. Okay, I'm jumping now. So P is equal to 0, Q is A multiplied by B is equal to 0. So P implies Q means what? If A is equal to 0, then A multiplied by B is equal to 0. This is of course true statement, no problem. Inverse means what? Not P implies not Q. So you just not it. So if A is not equal to 0, then A star B is not equal to 0. Obviously this is false. When A is not equal to 0, I have not said about B, B can be 0. So how you will guarantee that A star B will not be equal to 0? This is true and this is false. So what about this? Not Q implies not P. So you just reverse them. If A star B is not equal to 0, then A cannot be equal to 0. Yes, 100% this is true. Try to think about mathematics. A star B is not equal to 0. That means what? Indirectly you are saying neither A nor B, they are not equal to 0. So I am saying that A is not equal to 0. This is true. No problem. So I have told that this and this are same. Contrapositive. Direct, inverse, contrapositive, converse. So what is converse? If A star B is equal to 0, then A is equal to 0. How you will guarantee? When A star B is equal to 0, A is equal to 0. I can say A is not equal to 0, B was 0. Obviously this is false. Okay. So this and this are same. This and this are same. You have got more clarity now. By logic, I have proved it. Previously, I have proved it by Boolean algebra. See this slide. I have told by Boolean algebra, and now I have told you by logic. P implies Q and not Q implies not P. Both are same, and not P implies not Q. Q implies P. Both are same. Okay. Please take snapshot. I will jump to the next slide.
Done, sir.
So now we will study translation. This is really very important. Many times question have been asked from translation. So try to follow it. So first is implies. Whenever you see the word implies, it means P implies Q kind of thing. So they will say P is A is equal to 0, Q is A star B is equal to 0. They will say A is equal to 0 implies A star B is equal to 0. Write it in logic. So you will write A is equal to 0 is P, A star B is equal to 0 is Q. Implies will move like this. So P implies Q is the answer. They will directly say such kind of thing. They will give English sentence and they will say convert it into logic. They will give logic sentence, they will say convert it into English sentence. Both way they can ask. Now A star B is equal to 0 implies A is equal to 0. A star B is equal to 0 is Q. A is equal to 0 is P. Implies means like this. So it is nothing but Q implies P. So they can ask the both ways. So you have to write both ways. Let me jump to the next slide. Please take snapshot. Okay, I'm jumping to the next slide now. If P then Q. Same. So I am just showing you the translations for P implies Q. Okay, first was implies. Keyword is employ. Implies. Next is if P then Q. Okay. So P, it rains, I carry umbrella. So if it rains, then I don't carry umbrella. It rains means Q. I don't carry umbrella. Q bar. If P then Q. P implies not Q. This is my answer. Directly. They will ask directly. Either they will say logic formula, convert it into English, English convert it into logic formula. Both. If it rains, then I will carry umbrella. P, I will carry umbrella Q. If P, then Q. So implication like this. P implies Q. So if P, then Q. So you will think it like this. P implies Q. Now if they say if Q, then P, we will say Q implies P. So simple. Not a big deal. So direction you should remember. Direction is like this. Let me jump to the next slide. Done?
Yes, sir.
Q if P. So you have to remember Q if P means like this. Direction. The only thing is direction which you should remember. Okay, if you are able to remember the direction, then no problem. Yes. So let me show you. If I can, if P is, these all things will be given in GATE exam. If these are not given, then how you will convert it? So P is if it rains, Q is I carry umbrella. So I carry umbrella if it rains. So if it rains is it rains. It rains is P, and I carry umbrella is Q. Q if P. So direction is like this. I have told you. No? So answer will be P implies Q. They will give both options. P implies Q, Q implies P. So you will tick on P implies Q. What about the scenario? I will not carry umbrella. Q. It does not rain. Not P. If so, I will
It
say
is
like
also
this.
sir.
Come again.
Nothing, sir. You wrote it. You wrote it. Not Q.
Okay. Okay. So not Q, and so direction will be like this. Okay. So finally we will say not P implies not Q. For this, logic is this. Yes. Let me jump to the next slide. Please take snapshot. Yes.
Okay, sir.
Q follows from P. So you have to remember direction is like this. Okay, the only thing which you should remember is direction. That's it. So A star B follows from A is equal to 0. So P is A is equal to 0, Q is A star B is equal to 0. So Q is this, A is equal to 0 is P. Follows from direction is like this. So you will say it is P implies Q. They will give both options, P implies Q, Q implies P. So you will tick on P implies Q. So follows from is a keyword. Okay. Let me jump to the next slide. P only if Q. So direction is like this. The only thing is which you should remember is direction. So P only if Q, direction is like this. So A is equal P is A is equal to 0, Q is A star B is equal to 0. A is equal to 0 is P, A star is equal to 0 is Q. So answer is P implies. Okay. Let me jump to the next slide. Q when P. Direction is like this.
So the
P.
previous slide, sir.
Okay, okay.
Here P only if Q.
Hmm. And
A
P
is
if
equal
Q.
to 0.
Both are different. P if Q is like this, and
Ah,
P only if Q is like this.
okay, so then A is equal to 0 and A into B is equal to 0, that is Q.
Ah.
P only if Q.
So direction will be like this. So P implies.
Okay, okay, sir.
P if Q, it will be changed as Q implies P. P only if it will be changed as P implies. You have to remember directions only.
Okay, sir.
So Q and P, direction is right to left. So P is it rains, I carry umbrella. It rains is P, I carry umbrella is Q. So it will be like this. So Q implies P. They will ask directly questions like this. So they will ask it is equivalent to Q implies P, P implies Q, and so on. I carry umbrella. is Q, iterance is P, direction will be like this, so it will be P implies. Okay, let me jump to the next slide now. Q whenever P, same, whenever, one and the same thing only. The direction will be like this. So A is equal to 0, okay, I have forgotten. You have, see, A, what is A is equal to 0, what is A star is equal to 0, I have not defined it. This is not a question. So I will copy it. Yes, so this is given to you. Now question is correct. Okay, now they will ask. So A is equal to 0, A star B is equal to 0 is Q. When so the answer will be Q implies P. Okay, let me jump to the next slide now. Q unless not P or not P unless Q. See, you have to remember unless is nothing but or in logic. Or. Okay. So Q or not P, that is nothing but Q plus P bar, and it is nothing but P bar plus Q. One and the same thing only, and that is nothing but P implies Q only. So directly indirectly, your direction will be from here to here like A is equal to 0 is P, A star B not equal to 0, it is Q bar, and unless is here. So it will be like this. So Q implies P. A star B not equal to 0, that is Q bar. A is equal to 0, that is P, and unless. So direction will be now I think you will get confused here. So I see. Actually, I should not say direction here. You will get confused. I should not say direction. Now you should simply say like this: P or not Q. So that is nothing but Q implies P. Okay, you can change it like this: na P plus Q bar. P plus Q bar is nothing but, or you can say like this also: na Q bar plus में P. P plus में Q bar or Q bar plus में P, one and the same thing. P plus में Q bar or Q bar plus में P, one and the same thing. Now the moment you see it, you should think like this. Okay, it is nothing but Q implies P. Like I said, na P bar plus में Q. That is same as saying P implies Q. Like this. Same scenario: Q bar or P. So immediately you will say, okay, it is nothing but Q implies P. Okay. So now it's interesting question. Third is interesting. So here what you are getting, not P or not Q. So now you can change it like this also. Q implies not P or not P implies Q. You can say anyway. Okay, because you are getting not P or not Q, na? So not Q. Oh, sorry. P implies not Q. See, if you take like this, not P plus Q. So P implies Q na. So here Q bar you will get. If you take like this, so Q implies P bar, you will get like this. If you have any doubt, you just take it as X and you take it as Y. Okay. So finally, see P bar. Okay. So you just take it like this. Yes. P bar plus में Q bar. You take it as Y. P bar plus में Y. So P implies Y. Y is what? Q bar. So like this. And if you take it like X and you take it as not Q, so not Q or X. So Q implies X. So Q implies not P. So both ways they can ask. Okay. Yes. Please try to take. Please take snapshot. I will jump to the next slide. If you have any doubt, please let me know. Okay, I'm jumping to next slide now. Q is necessary for P. Okay, what is necessary? See, there are two kinds of conditions. Okay, let me show you first the direction, then I will come here. So Q is necessary for P So necessary will move like this. So you will say P implies Q. So I will say Q is necessary for P. Like this. P implies Q. So now there are two kinds of condition: necessary condition and sufficient condition. Okay. So whenever necessary condition is true, then our hypothesis can be either true or false. It hardly matters to me. That's why I have written question mark. When necessary condition is false, my hypothesis is false. So let me give you some example. So I will say two chapatis are necessary for me. Two chapatis are necessary for me. So I will say whenever I have not eaten two chapatis, my stomach will not be full. Obviously, it is true, na? So whenever I have not taken two chapatis, my stomach will not be full. So my hypothesis is false. But whenever I have taken two chapatis, my stomach may or may not be full. It entirely depends how much I am hungry. It entirely depends on my hunger, na? How much I am hungry. So because two chapatis are necessary, basic necessity. So whenever my basic necessity is not fulfilled, obviously my hypothesis will be false. Okay. And when my basic necessity is fulfilled, that means I have taken or I have eaten two chapatis, my stomach may or may not be full. That is the basic meaning of necessary condition. I will say 5 chapatis are sufficient for me. 5 chapatis are sufficient. That means what? Whenever I have taken 5 chapatis or whenever I have eaten 5 chapatis, my stomach will be 100% full. But whenever I have not taken 5 chapatis, my stomach may or may not be full. It entirely depends on my hunger. So now I think you have got it. When necessary condition is true, my hypothesis may or may not be true. But when my necessary condition is false, my hypothesis is false. Similarly, when sufficient condition is true, then my hypothesis is true. But when sufficient condition is false, my hypothesis may or may not be true or false. It hardly matters to me. Okay. So you have to remember like this. So necessary means basic necessity. When my basic necessity is not fulfilled, I am not satisfied. So finally, when necessary condition is false, my hypothesis will be false. When necessary condition is true, my hypothesis may or may not be true or false. It hardly matters to me. Sufficient condition. So it is sufficient for me. Whenever sufficient condition is true, my hypothesis will be true. But when my sufficient condition is false, it hardly matters to me. My hypothesis can be either true or false. It hardly matters. So true then true, sufficient. False then false, necessary. Okay, this is the scenario. So this is all about necessary and sufficient conditions. So now Q is necessary for P. So you will interchange like P implies Q. So A is 0 is necessary for A star B is equal to 0. A is equal to 0 is P. A star B is equal to 0 is Q. Necessary means like this. So finally we will get Q implies P as the answer. Okay. Q implies P is the answer. Please take snapshot. I will jump to the next slide. Okay, I'm jumping to the next slide. So last, P is sufficient for Q. This is the last translation. And then we will solve gate questions. Anyway, time is up. So I will solve these gate questions in the next class itself. So P is sufficient for Q. So sufficient means, see, direction is like this. P implies Q. Sufficient moves from left to right. Necessary moves from right to left. Necessary is moving from right to left. Sufficient is moving from left to right. A is 0. P, A star B is Q. Sufficient is moving from left to right. So answer is P implies Q. Okay. So they can ask question. Okay, that's it. This is more than sufficient for today's class. So in the next class, we will take the gate questions and all these things. Please take snapshot. I will wind up the class. If anybody is having any doubt, please let me know.
Yes, sir.
Okay then.